Hey everybody, this is Mr. Beckstrom, and today I'm looking at an example from section 5.1. This is 9, and it says express the following sums using sigma notation. So sigma notation looks like this. Looks like kind of like, man, that looks horrible. Take that back there. Something like this. And what we can do is we can start with some value down here. It's usually some integer. Most often we start with either a 0 or a 1, and then we'll end with some integer higher than 1. Let's say we end with a 10. And then we'll start with this integer here, and we'll keep adding 1 into whatever function or value that we put in for whatever k is in here until we get to the 10, and we'll keep adding those up. Let's look at an example here. So for number 8, how do we express 8 plus 9 plus 10 plus 11 plus 12 into this sigma notation that looks like this? So for example, if I had this and this was just k here, so the first time I'd put in a 1 for k, so this would equal 1, and then the second time I'd put in a 2, so we would plus 2, plus, and then we put in a 3, plus, and then we'd go all the way until we would finally get to plus 10, and that would just be 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10. So how would we just do 8 plus 9 plus 10 plus 11 plus 12? Well, let's kind of break this down. First of all, we're adding 5 numbers together. We're starting at 8, we're ending at 12, and we're adding by 1. So these are all important things to take a look at. So often we want to start, once again, with either k equals 1 or k equals 0. So in this case, let's go ahead and start with k equals 1. K equals 1. So if we start with k equals 1, in order to get 5 values, I want to end with 5, right? Because it's going to be 1, 2, 3, 4, and 5. And I have 5 values there. So in order to get the 8, what am I going to have to put in here? K plus what? K plus 7, right? Because if I put the 1 in here first, 1 plus 7 is 8, right? So then if I were to put the 1 in here, 1 plus 7 is 8. And notice that the next one I put in here is a 2. 2 plus 7 is 9. And then 3 plus 7 is 10. 4 plus 7 is 11. And then finally 5 plus 7 is 12. And we get exactly what we got there. So that's how we do A. Just k from equals 1 to 5 of k plus 7. Since we were counting by ones, that's why we just have k multiplied by 1, and then we just add 7 because our initial starting point was 8. All right, so for B, let's do the same kind of thing here. We're going to start with k equals 1. And we have 1, 2, 3, 4, 5, 6. This time we have 6 values, so I want to end with 6. We're counting by 3s, so I want to multiply my k by 3. So I'm going to do 3k. And let's see if I need to make any adjustments. My first value is going to be 3 times 1, which is 3. So that's exactly what I need. My second value will be, so 3 plus, and then the next value will be 2 times 3, which is 6. 6, and that's exactly what I needed there, right? 9 plus 12 plus 15 plus, and then finally the last one is 6 times 3 is 18. So that works out great for us. Now let's say I needed to start at, instead of 3, I need to start at 2. I could have just been like 3k minus 1, right? If I still was counting by 3s and left it at 3k. So, we can, we have our foundations, but we can make small adjustments in order to start at different things. But if I'm counting by 3s, that's where I want the 3 in front of the k. But there's some things that I want to leave and some things that I can kind of tweak as well. All right, C. Here, let's go. So we have k, and remember, so start with the basics, and then we can change it if we need to. So k equals 1 to 4, all right, because we have 4 values. It looks like it's increasing by 1, so I'm just going to put a k here, and the exponent is staying the same, so I'm going to put in a constant value for that. So this should be, when k is 1, that should be 1 to the 5th plus, and then when that's 2, that'll be 2 to the 5th plus, that's 3 to the 5th. That was a nice and easy one for us. 4 to the 5th, and then it stops. And finally D. So I have a horrible sigma notation, don't I? So k equals, row 1 again. All the way up we have 4 terms, so 4. On the top we're staying the same, so I'm going to leave that as 1. On the bottom we're starting at 4, but we're counting by 1. So I want to leave that k by itself. I don't want to have any multiples in front of it, but I'm starting at 4, so I want to add 3 to that initial k. So k plus 3. So when k is 1, that's a 4 on the bottom. When k is 2, that's a 5 on the bottom. When k is 3, that's a 6 on the bottom. And when k is 4, that is a 7 on the bottom. All right, guys, I hope this helped. And a lot of times it's just, it's starting with something and then tweaking it until you get it to work. If you have any questions, let me know, and I hope you have a great rest of your week. Thanks.